Hi everyone. Today we will continue our discussion, and actually today we will start module 3, which is automating data operations. So today we will learn about flowcharting and also an introduction to programming. So this is kind of a preparation for exam 2. Exam 2 will be next week, and those are some of the requirements that you will need to prepare. So you cannot use any external resources, and you will also use a PC. It's recommended that you use a PC, not a Mac, because a Mac might give you some problems, especially when you are working with Excel. But my recommendation is that you use a PC. And remember, you can borrow a PC from the Price School Business. And the essence, or the best way to prepare, is to practice and practice with Excel. So you have done a lot of assessments and the homework and also the lecture exercises, so that should actually help you get better. So today again, so we have covered actually so far the first two modules. So we covered storing and retrieving data using SQL, and we also covered analyzing and visualizing data using Excel. And today we will actually enter into automating data operations. And a lot of people actually, when they start this module, they start with this statement: I hate programming, I hate programming, until it works, and then they love programming. And I'm sure that you will all love programming after we practice this module. So what is the purpose of programming? So programming, actually the purpose of it is that it automates processes for us. So it automates certain tasks that are repetitive. Instead of hiring someone to do those repetitive work for us, it is actually much cheaper if we have a computer do those repetitive actions or tasks for us. So again, programming is when we tell the computers to do certain tasks for us, basically, to keep it simple. So how does programming work? So again, we write a code or programming code that tells the computer what to do. So again, for us, when we actually write a program or a code, actually we need to write it in a source code, and this source code can be in any of the following languages: programming languages such as Java, JavaScript, SQL, Python, C++, C#, Visual Basic, or Visual Basic for applications, the one that we will be using for this module. So computers, unfortunately, they don't understand the source code, or they don't understand the plain English language that we use when we insert information in an application, for example, or in a form. Therefore, computers understand only machine language, which is a binary language, which is basically zeros and ones, and which basically means on and off, yes or no, or true or false. So we need to translate this source code into machine language, or into binary language, for the computer to understand what we want it to do. So to do that, we have the source code. It's actually transforms or translated into assembly language through an interpreter or compiler, and then the assembly language is transforms into or translated into machine language through an assembler. So I just wanted to highlight Grace Hopper, who actually was one of the earliest computer scientists who introduced the term debugging, or a bug, to us. So remember, when we say the computer or there is a bug in the system, that means that there is an error in the system. And actually she also introduced to us the COBOL language. It's one of the languages that I was trained a long time ago in, and actually some companies still use COBOL, such as Walmart, which is kind of strange to some extent because there are so many other newer languages. But it's anyways, so the bugging or the debugging concept actually was introduced as a result of a real bug Actually, one of the earliest computers was so huge, and at one point it stopped working. And then when they went inside that computer, which was kind of almost in the size of this room, they went inside that computer to see why the computer stopped working. And then it turned out actually they found a bug, a real bug, like a cockroach or just a real bug inside it. And since then they have been calling an error a bug, and to fix that bug they call it debugging. And again, where should we start when it comes to programming? So it all starts with coming up with that logic, or what we call it is a flowchart or a storyboard. So we write this or we draw it in a flowchart format using the lucid chart that we will learn about in a little bit. So after we actually are able to draw that flowchart, then we would be easily able to program and code. All right, so what do we mean by flowcharting? So flowcharting actually helps us automate those business processes and put it for us in a logical format, in a visual format. So that way we need to understand the process before we start programming it. So the flowchart helps us understand that process by going through the input, the process, and the output. So flowcharting actually is used widely when it comes to software development, and it's also used for business process modeling in terms of workflow, and also it is used for decision process modeling. So again, when we draw the decision logic in a drawing or in a picture, it is much easier for us to understand that process. So this is a simple or an example of a flowchart or a logic decision that we need to make and how it flows. So should you eat that bacon? So do you want to feel? So I will let you read this and you will understand what we really mean here by a flowchart and how we create it. So in order to understand flowchart concepts, we need to understand the process or the input, process, output. So to do that, we will actually, let's imagine or think about if we want to create a pancake. So what are the input ingredients for that pancake? So we need to specify and list the input ingredients for the pancake. So it is, you might actually guess that the input includes the flour, the eggs, the milk, and so on. So let's see. So it includes all of that and sugar. And then when we, the process for making a pancake, actually to mix all of those ingredients and then with the food mixer and also then cook them. So that's the process. And then the output will be actually ready to eat pancakes. So very simple to understand the process or the input, process, output. So what if you bought, let's say, a shelf or a bookshelf online from Amazon or from Walmart, and when you receive it in pieces. So what is the process, or how would you assemble it, or how would you fix that and make it ready? So we need to go through the input. So the input for the bookshelf will be actually the tools, or also the different pieces of that bookshelf. And then the process is to assemble those pieces, and the output will be ready to use bookshelf. So very simple. So now let's think about the process, how we can model the input, process, output about your course evaluation in this course. So what would be the input for your course evaluation, for your grade evaluation in this course? So it includes the homework, participation, exam, and quiz. So those are all the input for me in order to process and come up with your final grade in this course. So the process is to do or to score your grades based on the weights for each of those input. So as you can see here, based on the weights, then I will be able to see your final score or overall score based on your overall score, I will be able to decide what your letter grade will be. So the output will be the score and the grade. So we need to understand the flowcharting symbols before we start drawing them. So the first symbol, as you can see here, this is, we call it the terminator, which is actually when we start a flowchart, we need to start with a terminator, and we call it start. And when we end a flowchart, we end it with a terminator. So this is a rule of thumb, and it's very important that we remember this. And then the parallelogram shape, actually we use it for input and output data. So for example, when we did the pancake, so we need to put that the input inside this parallelogram shape. So the input and output, when we show also the output, which is, let's say, your score and your grade, we put it as an output here in a shape of parallelogram. And we will actually practice, and you will remember this. So we'll practice some more. And then the third shape is the rectangular, which is representing, we use it when we are processing something. So when we are doing a calculation, or when we are doing some actions or tasks that we want the computer to do for us, then we use this rectangular shape. So the arrow here just represents the flow from the previous step. And then we have here the diamond shape, which is actually representing a decision. And always when we read the diamond shape, we read it in the form of question. And the decision always has a true or false or yes or no output from it, or outflow, or flow arrow from it. And then we have the connector here. If we have more than one process that they meet in the same place, then we use the connector. All right, so now let's start with an example. So let's say that you were asked to create a software that calculates the amount of income tax you owe on a paycheck. So we will assume that you have a flat tax rate of 25%. And so the process should accept the paycheck amount and do the calculation. So by reading this last bullet, I kind of understand what I really need to include in that flowchart. So the process should accept a paycheck amount. So basically my input should be the paycheck amount, and then do the calculation. So my process is the calculation of the tax, and then the calculation of the net pay, and last, and print out. So the printout, basically this is my output or the display, and print out the tax amount and the net pay. So now those are kind of, if you remember those rules of thumb of how to create a flowchart, you will easily be able to create any flowchart scenario that I give you for the homework and also for the exam, and so on. So the first step, when we create a flowchart, we read the scenario, and then we go through those 6 steps. So the first step is to decide and define what variables will be needed. So in this case, our variables that we will need include the amount or the paycheck amount, and the tax, and the net pay that we will get. So those are the 3 variables that we will use. So that's the first step. Second step is actually to start with the start terminator, or the start shape. So this is the start shape. So this is very important. So we start every flowchart with the start shape. And then take input as needed. Remember in the scenario that we looked at in the previous slide, it says the program should accept the paycheck amount. So in this case, our input should be the paycheck amount, because we want to know what is the paycheck amount in order to be able to calculate the tax and also to calculate the net pay. So now the process in this case, we need to calculate the tax. So the tax, they already told us it is 25%. So in this case, in order to calculate the tax, we already have it here, will equal the paycheck amount times 0.25, which is the 25% tax. And then the net will be the paycheck amount minus the tax that we just calculated earlier. So we will put it here in the rectangular shape. Now we need to display what we just calculated. So to display, and they said we need to display the output. So our output in this case, they want us to show the tax, and they want us also to show the net pay. So in this case, show the tax and the net pay, and the last step is to end it with a terminator shape. Very good. So this is very simple. So now let's move on to a little bit more advanced example. So now let's think about when you become a little bit more richer, and let's say that you have extra income and you want to invest that amount today, and you want to know in the future how much you will make in the future. So in this case, I need to know the amount that I am going to deposit today. I need to know also what is the interest rate that will be applied to this investment, and also I need to know for how many years I want to keep it. So those are basically what I have. So I need the deposit amount, the interest rate, and also the number of years. So in order to calculate the future balance, you will need to use this formula. So deposit times 1 plus interest rate raised to the power of n, which is the number of years. All right, so now what they want us is to create a flowchart that calculates and displays the balance in a savings account. Very straightforward. So now we'll go through the same logic that we talked about. So what are the variables that we will need to create this flowchart or this software or program? So I need to know how much amount I want, or the deposit, how much amount I want to invest, number of years I'm wanting to invest, and also the interest rate. So those are the variables that I want. In addition, I also want to know the balance. So those are kind of the variables that I need. So I list them here as a legend. And then the second step is to start with a start shape. Very straightforward. And then we have to end with an end shape. All right. So then after the start shape, I need to take the input. So in my case, the input will be the deposit, interest rate, and number of years. I'll put them. And then I will need to model the process. So the process in this case will be that formula that was provided to us to calculate the future value. And then I will display, in this case, is the balance. Maybe I can, even if they ask me, I can include also the deposit amount or the number of years and interest rate. But what I really want to know as an output, I want to display the balance. So this is how it will look like. So now, so far, so easy, straightforward. So I will let you read the flowchart rules. So now we have actually used the terminator, which is to start and end a flowchart, and we also learned how to use the parallelogram for input and for output. So the input to accept those values that we want to enter into the system, and also the output, which is the display or to the print that we want to show after we do the calculation or the process. And then we have the process shape, which was actually the calculation in this case, and we also use the flow. So far we haven't used the decision and the connector. So now let's look at one example in which we will be using the connection. Actually, we will be using the decision, which is for conditions, and also will be use the connector. So now think about Captain Beefnut, who owns a Beefnut donut shop, and he decided that he wants to give discount if an individual buys 12 donuts or more. So he will sell each donut for 40 cents. On the other hand, if an individual buys less than 12 donuts, then he will charge them actually 40 cents. I mean 60 cents. So again, the more you buy, the more discount he will give you. So basically, if you buy more than 12 donuts, then you will get them for 40 cents. Less than 12, you will get them for 60 cents. So now he wants us to create an application for him or a flowchart for him. So to do that, we will follow the same thing. So what are our input? So what are the variables that we need to know? So the variable that we need to know as an input for us is the number of donuts that the customer is wanting. And then also we want to show what will be the balance or the price or the cost or the bill. Actually, we can call it a bill. So our input is the number of donuts, and the output will be the number of donuts and the bill the customer has to pay. All right, so the same thing, the same logic. We will start with a start determinator. The input will be the number of donuts, and then we will use the diamond shape here, in which we will be looking at the decision, or so in here the decision will be the number of donuts. If the number, so we call it here as, we always read the diamond or the decision shape as a question mark or as a question. So is the number of donuts greater or equal to 12? If it is yes, then we say the bill equals 40 cents times the number of donuts. If it is not greater or equal to 12, then the number of donuts times 60 cents. The bill will be 60 cents times the number of donuts, and then we will be able to print the bill and the number of donuts. So you got the idea now how to use the diamond shape. So we use it if we have a condition or a logical condition. So what about this example here? So Jodo, he actually started this business of buying used phones and selling used phones, and he wants us to create software, but before that flowchart to decide whether he is losing or making a profit out of those phones that he buys and sells. So to do that, we need to understand, or as an input, we need to get the cost price, and also we need the selling price as an input in order to be able to have then a condition. So now we have a condition. If the cost price is, or if the selling price is greater than the cost price, then we actually have a profit. If the selling price is less than the cost price, then we have a loss, and we need to calculate that. So that's what he wants us to do. So this is the solution for it. We need to identify first the input, cost price and selling price, and then the output will be the profit or loss. So we start by introducing our input, which is the cost price and the selling price, and then we go through a decision or a condition. Is the selling price greater than the cost price? If it is yes, then we will calculate the profit, which is selling price minus the cost price. And then if it is not, then it is going to be a loss, and the loss will equal cost price minus the selling price. So then we will just display whether it is a loss or a profit, and then they connect and we end that program. So this is another example. Now I will let you go over the other examples that I have provided to you. That way you can practice more. So this is a subway ticket purchase. So we have 3 types of tickets, and also every type of ticket has specific price to it. So we have single ride, $2.25, weekly pass $25, and monthly pass $100. So now they want us to calculate, or to use as an input, the type of ticket and the number of tickets, and they want us actually to calculate the cost per ticket, or the cost per ticket and total cost. So basically they want us to show the total cost and the cost per ticket. So here, since we have 3 conditions, so we need to use that diamond shape because we have more than one condition. So if the ticket type is single ride, then the cost will be this. If the ticket type is, let's say, weekly pass, then the cost will be 25. So that's why we need to use the diamond shape for conditions. So this is how we will draw it. So for the homework, you should always use the legend. Basically here you are defining what the abbreviations that you are using here and what they really stand for. So we start with the terminator, and then we have the input, the ticket type, number of tickets, and then single write cost, and then weekly write cost, and monthly write costs. So then the first condition will be, what is the ticket type single? If it is yes, then the cost per ticket will equal the single ride cost, which is 2.25. If not, then we go and ask another question. Is the ticket type is weekly ticket type? If it is yes, then the cost per ticket will equal weekly type, or the weekly pass cost, which is in that case whatever it was. And then if it is none of those, then it is going to be the monthly pass, and we already know the monthly pass. So now we are going to calculate the total cost, which is the cost per ticket based on the condition. It's going to be either one of those three times the number of tickets, and then when we know the total cost, we can display it, and then display the type of ticket and number of tickets and so on, and then we can end it. So it should be straightforward. Again, here we have commission calculation. So salesperson, if the salesperson makes less than 1,000, then their commission rate will be 10%. If they make between 1,000 and 5,000, then their commission rate will be 20%. If they make more or equal to 5,000, then their commission rate will be 30%. So they want us actually to calculate how much commission that salesperson will get. So now we have three conditions. So we need to have those diamond shape in order to calculate that. So we have two different ways to calculate this. We can use it, we can create it in an if statement format in the left side. So if the sales is less than 1,000 and it is true, then the commission will equal 10% times the sales amount. If it is not less than 1,000, that means is the sales less than 5,000? If it is less than 5,000 but greater than 1,000, then the commission will be 20% times the sales. And then if it is greater than 5,000, so then it goes to the commission will be 30% times the sales amount, and then we can print the commission. Then here we use case select or select case. So this is a different way we can actually create this software or this program. So if the case is the sales is less than 1,000, then the commission equals, and so on. And we will actually practice using the select case in one of the next lectures. So now you get the idea, and I will let you actually read this department just for more practice. You can actually start drawing it and then compare it with the answers just for practice. That way you can do the homework and do the exam question really well. All right, so now this is another example. I will let you go over it. So now let me take you to Lucid chart. So let's create a flowchart in Lucid chart. So let's create one of those guys, the earliest one that we did. Let's do this one. So to draw this guy, so we should already have flowchart. If you don't have it, you can always look for it here. So flowchart shapes, that's what we are really interested in. So we already have them here. So I'll start with the terminator. So I'll call it start. And then I need this parallelogram, which is the input shape. So I'll just put it here and connect this guy. And the input. So the input in this case is the deposit, and then the rate, and also the number of years. Now I will need the process shape, so I'll just drag it and drop it here. So the process shape here, balance equals d times and then 1 plus r raised to the power of n. Alright, so then I will just put the display, or what we call it, the output shape. Let's see here. So the output shape in this case, I need to print B, and then I will end. I can create now the end, the terminator, so I'll just put here end. Double click and end. Very straightforward, very easy. Very good. So now I can print this guy like what we did in the previous example. So I'll just download, and this looks really nice. So you got the idea now. Very simple, very straightforward. So this is all that I wanted to cover in this lecture, and then we'll continue with loops in the next lecture.